Today, geothermal electricity generation only accounts for 0.4% of the total power generation in the United States. And this is 0.4%. Geothermal is the energy within the Earth. Geothermal energy is one of our more promising energy sources. It's an energy source that is reliable and is sustainable. But current geothermal production comes from really shallow wells, as we can see on the image on the right. These shallow wells are drilled to depth between 1,000 to 5,000 feet. And this is a really shallow depth compared to the thickness of the earth crust. So what's holding geothermal back? Current geothermal, again, is being produced from these really shallow wells where we encounter the heat closer to the surface. This happens in regions when we have volcanic activity and we will have a thinner earth crust. One of the examples of this is the geysers field, the geysers geothermal field, one of the biggest geothermal complexes in the world. In the geysers, they inject water, or this is treated wastewater from shallow wells. This water will flow through the rocks, through the fractures within the underground rock, and then start heating up and gaining temperature. We're producing this hot temperature from producing wells, and the vapors that are generated from this hot temperature, from these hot fluids, will move a turbine that is connected to a generator, is driving a generator for electricity production. These type of geothermal systems, when we have the heat very close to the surface, they're very rare. And that is what is preventing the full potential of geothermal energy until now. I am a petroleum engineer, and I believe that we can leverage the expertise of petroleum engineers to unlock this deep geothermal energy and then realize the full potential for geothermal energy. Petroleum engineers already know how to drill deep wells, how to inject fluids into the ground, and how to produce these fluids and lift these fluids to the surface. Petroleum engineers also know how to manage the fluid flows within the rock and within these reservoirs. By leveraging the expertise of these petroleum engineers, we can also drill deep enough and find the temperatures that we need for electricity generation. I started studying geothermal systems, or deep geothermal systems, 10 years ago when I started my position here at Mines. I started working with this in collaboration with NREL. We were looking at the DJ Basin and the Wattenberg Field here in Colorado, and we were looking at the potential to producing geothermal energy from these formations. With a team of 3 graduate students and 9 undergraduate students from the Petroleum Engineering Department here at Mines, we were able to build a model of the Earth using data from oil and gas wells in the Wattenberg Field. We can see in the right, there is a high geothermal anomaly in the Wattenberg Field. We can see a temperature map that was developed with the temperature logs from the bottoms of the well. And the red colors are indicating the high temperatures at the bottom of the wells. This one is Megan, one of our graduate students. She's looking here at a computer model that we use for evaluating the production of geothermal energy from these sedimentary formations. We were looking at the Lions Formation in the Wattenberg Field. In these models, we're using a well to inject cold fluids into the reservoir. These fluids will flow through the rock and then will heat up, and we will produce these fluids in another production well at temperatures at the surface that are required for electricity generation. Something that we learned in this project was that when we're injecting this cold water, eventually we'll be cooling down the reservoir. So we were trying to design the optimal system, considering the well spacing, that we can produce this higher temperature for a longer period of times. We were targeted here for 30 years. And this is very important information, the time that we're going to be producing these high temperatures, because it's going to be impacting the economy of these geothermal operations. Another thing that we learned, that is the conclusion of our project here, was that we needed some kind of well stimulation. We needed to have hydraulic fractures in our well to increase the flow, the injection flow rates, and the production flow rates using hydraulic fracturing technology similar to the ones that we use in oil and gas wells in order to sustain this production and to make feasible the production of geothermal from sedimentary reservoirs. More recently, I was also invited by NREL this time to study advanced geothermal systems. Advanced geothermal systems are also known as closed-loop systems, where we inject in a working fluid down a well, but the fluid will never leave the well. We will not get into the rock. It will remain contained within the pipes of the well. We look at, with a graduate student from the Petroleum Engineering Department at Mines, we were looking at different well configurations for these advanced geothermal systems. We look at a single well configuration. When we have the pipe-in-pipe configuration, we inject the fluids, the cold fluids, in a larger diameter pipe of the well. When these fluids are flowing down to the formation, they start heating up and gaining temperatures. And then we can produce these fluids from an inner thermal insulated piping tubing or production tubing. And we can lift these hot fluids all the way to the surface. Another configuration that we studied was the U-shape configuration. In this case, we drilled 2 wells. We get to the depth, the target depth when we have the higher temperatures, and then we connect these 2 wells at the bottom of at the surface or at the formation rock that we're trying to target. We inject cold water into one of these wells. The water will start heating up when it's flowing down the well, and then it's going to start gaining more temperature in the horizontal portion of the well at this target depth. And then we produce this higher temperature on a thermal insulated pipe. We also look at different working fluids where we're looking at CO2 for geothermal in closed-loop systems or water as a working fluid. And we're trying to look at how these systems should look like, how we can design enhanced geothermal systems so we can actually produce the temperatures needed for electricity generation and sustain this production for a longer period of time. With my grad student, we presented a paper in a geothermal conference, and we got 2 really good outcomes from this conference. One, my student got a job as a geothermal resources engineer with a geothermal company that is operating in Utah and Nevada. And I got a call from Occidental Petroleum, Oxy, that is an oil and gas company. They invited me to participate in a proposal for a geothermal proposal. Our proposal was accepted by the DOE to conduct a $27 million project where we're going to be drilling 2 wells in the DJ Basin here in Colorado. This project is called the GLADE project. It stands for Geothermal Limitless Approach to Drilling Efficiencies. The purpose of this project is to surpass the limits, the current limits that we have in geothermal drilling by drilling 2 twin high-temperature geothermal wells very fast. We're planning on drilling these 2 wells next year to a total depth of 20,000 feet. So 20,000 feet is double that the typical wells that we're drilling in the DJ Basin. And also it's much more deeper than the wells that we use for geothermal. The temperatures that we're expecting to reach at these 20,000 feet is above 500 degrees Fahrenheit. But one of the challenges for deep geothermal will be to inform and to optimize the shape of these wells and being able to produce the high temperatures all the way to the surface. And here is where the petroleum engineers and their technical skills are well posed to have significant contributions into the geothermal energy. By being able to drill these wells and adapt our drilling technologies to drill faster into hard rock, to deeper depth, to inject fluids or to develop the technologies to inject the cold water into the reservoirs, and then to produce and lift those fluids back to the surface at the temperatures required for electricity generation. And then also designing strategies to manage how these fluids will flow within the reservoir, so then we can sustain or sustainably harvest the Earth heat. But this is the challenge for deep geothermal, is to being able to lift all these fluids from deeper depth all the way to the surface at the temperatures required for electricity generation. And this is the challenge that has limited the expansion of geothermal energy in other places, and is only limited to when we find the hot temperatures at shallow depth. At Mines, we're shaping the future of energy by developing technologies that advance and modify and adapt oil and gas technologies. The green economy doesn't need to leave anyone behind. With the development of these deep geothermal resources, we will be able to have a significant impact in the economy and the well-being of our societies or our communities. Thank you.